Hey everyone, thanks for joining me. Today I have a super special guest, and I'm super excited for this one. This is Evan, and he is from Celestia. So thanks for coming on, Evan.
Thanks for having me. I'm super pumped too.
Yeah. So this episode, like you work at Celestia, but we're mainly going to be diving into Blobstream, which is, I guess you could say it's the bridge from Celestia to Ethereum. How would you kind of describe it? And
I don't know if I'd call it a bridge. People say that, and I don't correct them. Like
okay,
it's not the word I would use, but if someone says it, it's not like, oh, I'm going to be like a real big stickler on definitions because the point's the same, right? It's kind of like a bridge, except for it's a one-way bridge, right? So a more accurate term, I believe, is like a light client relay.
ooh, okay. So it's a light client relay. So I guess before we jump into kind of how it works, what was sort of the problem you guys were trying to solve? If you want to give like an overview of how you sort of got to building it.
Yeah. So the best type of DA security is if you're doing sampling yourself. But unfortunately, you can't do that if you're using something like a smart contract because it's too easy to game and it really doesn't, like submitting samples on chain doesn't really do that much. However, using a data availability committee is also bad. So it's presumably like the problem, right, is that just that rollups need more data to store their block data on Ethereum so that they can settle to Ethereum. And the problem with that, or the problem with using something like a data availability committee, if you want like cheaper transactions, I think at the time, whenever we started this, the cost of call data was kind of insane, and then, it always depends on like whatever the gas price is. So it was, I think, it was reaching some absurd percentage of like a rollups, like the cost of running a rollup it's getting insane, like millions of dollars, like tens of millions, to the point where like if I don't have a bunch of VC funding, I can't really like do this. I can't start. I can't innovate, right? Which is kind of bad. So we need some sort of cheaper form of data, but we also want it to still be secure and at least or like relatively secure. We're never going to get to the point where data is posted on the same chain. That's by far and away the best. So I would never claim that like using an off-chain DA solution like this Blobstream, like this light client relay, is more secure than something like just posting call data to Ethereum. But it also can be significantly more secure than something like a data availability committee. So a data availability committee is literally just like a raw oracle. It's just like I just sign something and I say the data is available because I said it's available, which is like,
It's a
okay,
whitelist,
great.
right?
And what are the consequences there if you don't hide data, or if you hide data? It's like your reputation, maybe. So like I mean, this is like the problem with most oracles, right? Is that you don't really have a lot of security here. So you don't actually have like a way of slashing. So what a light client relay does is we're actually having this data off chain, and this data is attested to by validators on Celestia, and then that attestation is relayed via light client to Ethereum, to these smart contracts. Doesn't even technically have to be Ethereum. One of the biggest use cases for this is actually an L2. Like a lot of L2s are really interested in this, so that you can have something like called an L3 or something. Whatever you want to call it doesn't really matter. It's a bridge,
For a
okay?
different
And,
argument,
and
different time.
yeah, yeah, exactly. But so these attestations that get relayed to Ethereum, to some EVM chain, just attest, and it's very similar to a data availability committee, right? We have a committee, in this case, it's a validator, and in this case, a validator set, and in this case, the validator set is selected by token holders via delegation, etc. And they sort of just say, in a very similar way, right? They're just saying the data is available because we said it was available.
Right.
But they're doing something different where they're reaching consensus, which is again very similar to like what a data availability committee would do, except for the fact that if they hide data, they get slashed via social slashing. So there's like when validators sign on something on Celestia, there's two things that can happen. Either that data is available, or they signed over hidden data and they're going to get socially slashed. And the cool thing about Celestia, perhaps the coolest, of course, is while this doesn't necessarily add security in the most direct way possible, is that you have light clients that can sample this data. So you can determine. So that's only important because like remember what we said with the smart contracts. It's like if I'm posting these samples to a smart contract, it doesn't really do anything. Doesn't provide any extra level of security because it's so easy to game. However, if it's very cheap to verify that the data is available, then that means that more people do it. And more people is good because that's how we reach social consensus. It's very easy to see if the data is available or not because I can run a light client. I don't have to download all of the data myself. I can just download a very small portion of it. And in theory, you can download it. You can just run your phone. Things like this. So that's sort of like the unique aspect of this is that I can sample this data. I can see if it's available. We can reach social consensus, and if the validators post hidden data, they can still perform the attack. So the attack still does go through. However, they will at least get slashed for it. So it's significantly more secure than something like a data availability committee, which doesn't get slashed. Well, there's just no guarantees. Like, I mean, that's pretty much it. Yeah.
Yeah. Well, maybe we can take a step back, and I that was like a super great overview, but to kind of explain for people watching, like the big problem is over here on rollup land, like you're a rollup to Ethereum, you get bridged assets, and some sequencer or whatever is doing a bunch of transactions, and you have a new token balance over here because people are sending you stuff. Um, the fear is that either you have to run your own full node over there, and basically hold your own data, because ideally what would happen is if the rollup shuts down, you can then go back and withdraw your assets on Ethereum, right? You could potentially or do a
Even if
forced
you're
exit,
running,
right?
even if you're running a full node, the sequencer, if the data availability committee can still hide data and the attack can still be done. So you as a rollup full node, it's the same thing as running a light client, like running a light client on Celestia and running a full node are very similar levels of security. So you still have the same problem there. Is like it doesn't directly contribute to security because while I can detect that data was hidden,
Right.
or I could detect that the rollup sequencer had something fraudulent, or no, I wouldn't be able to do that because they hid data, right? Well, then if they're hiding data, they can still perform the attack on Ethereum. They can still say that like, oh, look, the data is totally available. Trust me. And then, but it's totally not available, and then they perform the attack. That happens no matter
So
what.
what would, if you could like take it away from saying, calling it data, like what would be an example of like a data withholding attack, as far as like how would somebody be able to do this to spend your ETH and steal your bridged ETH or something like that?
So if it's an optimistic rollup,
Yep.
I can hide data and just produce a state root, an arbitrary state root that I choose. And I can post that state root and I post my header, and then no one can download the data since the data is hidden. No one can download it to produce a fraud proof. So because I can change the state in an arbitrary way, I can take the entire bridge's funds. Like I can run away with everything. And that's the reason why you have like the fraud proof window, right?
Yep.
But in order for that fraud proof window to work, you have to be able to create a fraud proof. And if you're hiding data, you can't do that.
Right. So
And then for
if he doesn't
something
have
like
the
a
data, so what you would do is, in normal, like a normal roll up would just, or I guess not that there's a normal roll up, but
LOL.
right, like the idea a lot of times, like Arbitrum or Optimism, they'll just post data directly to Ethereum. So like it's sort of finalized once it's pushed to Ethereum. But as you were saying, that's super expensive. So what we're gonna do is we're gonna post it over to Celestia. Celestia is gonna hold it, and then if you want to view it on Ethereum, there's a way to basically, what you're going to do is run a light client on Ethereum of Celestia, and that's what Blobstream is. Right?
Yeah.
Okay.
Celestia's or Blobstream is a on-chain light client as opposed to an off-chain light client. So
Right.
an off-chain light client is the one that can do data availability sampling and actually get more security that way, as opposed to an on-chain light client. On-chain light clients cannot do data availability sampling. So you just have to have honest majority assumption there. We're trusting the validator set, that we're trusting that at least 1/3 of the validators are honest.
So, okay. Real fast, can you explain the difference between like client security with the honest majority assumption versus with data availability sampling?
Yeah. So
Okay.
while an off-chain light client, since it's listening for fraud proofs. So Celestia has fraud proofs for every possible block validity rule. Celestia has a fraud proof for. So things like error share encoding, the way that the data is structured in the square. Eventually, we'll have some sort of solution for like proving the state transitions on Celestia, similar to a rollup. And then you have data availability sampling. So because your sort of data availability sampling right convinces yourself that the data is available, and because I'm listening for fraud proofs or validity proofs, now I'm convinced that the entire chain is secure, although I didn't actually have to run a full node. So I'm having the same level of security essentially as a full node, even though I'm running it from my phone, which is kind of crazy, right? This is sort of like gets back to the core of crypto, of like Bitcoin, right? The some of the Bitcoin community is toxic, but they do have one amazing saying, right? It's don't trust, verify. Because and that's very important because you can literally secure the entire chain, right? Like the hashing power isn't the thing that secures your Bitcoin. It's running a full node that secures your Bitcoin, right? The only thing that's preventing 21 million is because we all choose a binary that says that there's 21 million and we verify it ourselves. Light clients have that same property here because we're just getting very clever by making it way cheaper. So instead
Yeah.
of having to run a full node, we're having something that you can run from your phone, and like in theory, you can literally verify the entire financial system from your phone. And that's important, right? Because what makes Bitcoin only have 21 million is because we choose that a binary has 21 million. Light clients get that same property now. So that's sort of like the superpower that is an off-chain light client, where something like an on-chain light client, much more lame.
Yeah, well, I think like most of the times, like when I think
So
of a light client, I think of the more on-chain light client, if you will, like just verifying sort of honest
mhm.
majority assumptions. But then, Celestia, for to explain kind of what you guys did was it looks more like a data storage network, similar to like an IPFS in my mind, where, like basically the light clients itself are basically parsing the data and you're only verifying a portion of it. But since everybody's only verifying a portion, then it's very secure. Is that right?
Kind of, yeah. So the data availability sampling, I want to very much distinguish between something like IPFS and something like Filecoin, where those are amazing networks and they have like a lot of like long-term storage. Like Filecoin has incentives for long-term storage. However, they don't have guarantees for short-term data availability, for like high-level security guarantees there, and that's very crucial in the case of like something like a rollup. So you get those high-level security guarantees by having these data availability sampling over the data. So we have our original block, and we sort of organize this in a square, and then we do error share encoding. So error share encoding is like what QR codes use and like CDs use. Like I don't, maybe I'm dating myself, but you can have a CD and you can like scratch the snot out of it, right? And you could put it on a CD player and it would still play. And it's like, how is that possible? And it's because it had something like this error share encoding where I can corrupt data or hide data or do whatever, right? But because at least over 50% of the data, I didn't scratch up over 50% of the CD, it will still play music because the CD player can recover the rest of the data using error share encoding. So we do that same trick, but we do it 4 times, or technically 3 times. We have the original data, and then we error share encode it once, we error share encode it twice, and then we error share encode in this section again, a third time over here. And the maybe that's getting into too far into the weeds, but the point being that like now if I want to hide data, what do I have to do? With the error share encoding, right? If I have a CD, if I'm trying to erase a song on a CD, what do I have to do? I have to scratch out over half of it, and then whatever the song is. So I have to. So if when I'm sampling, if I just want to see, guess if a song is recoverable on the CD, right? What do? I could take random portions of it and sample it. And each time, if the sample is truly random, right, I've got like a roughly 50% here in the CD example, I've got a 50% chance of that sample coming back scratched. So if I just see that if the sample comes back or not, then that means that there's a 50% probability, and you do that a few times, and now all of a sudden you're at 0.99.999 something percent confidence because you're reducing by 50% each time, right? It's exponential. So this is how the sampling sort of works: is you're convincing yourself that no data is hidden, and then there's a second part of this, is because you're also convinced that there are enough light clients in the network that are also sampling. So in the worst case scenario, where the validator set signs over hidden data, and they only want to convince you that the data is hidden, or they want to convince a large, like a subset, that the data is not hidden. So they'll serve samples to you, but then not serve samples to other people. You have to be confident enough that enough light clients are sampling so that they can reconstruct the data. So if that happens, so there's basically two things that can happen here. This is what the goal of this entire sampling process, and assuming that there are enough light clients sampling has like the benefit of either the data is available or the data is hidden and we're slashing. And if I sample then, and I make that assumption, then I'm very 99.99 something percent confident that the block data is available. And the last thing is the number of light clients that have to be sampling are dependent upon how big the block is. Not really how big the block is, how many samples are in the block. So we break the samples up currently for the max square size. It's like 128 by 128. I forget the numbers on this. It's in the Lazy Ledger paper, though, I believe. Or no, the paper from 2018. Yeah. Data availability and fraud proofs by Mustafa Ablosam. He's the CEO of Celestia, and Albert Sonino and Vitalik wrote that paper. It's a really good paper if anyone hasn't read it. But anyway, the number of light clients that you need is based on that number, like how many samples are in the square.
Okay, super cool. Well, yeah, let's get back to kind of talking Blobstream. Let's.
Yeah, sorry.
No. It's super good. It's this is important to figure out why. Because so Celestia,
on-chain light clients.
On-chain light client.
Like Blobstream, they don't get these guarantees from data availability sampling. And Blobstream specifically also, not yet at least, doesn't verify any of the other block validity rules. So one of the block validity rules is that the error share encoding is done correctly. Because I could just make up random error share encoding data, and then you do samples, and then it means nothing, right? So you have to be convinced as well that the error share encoding was done correctly. So Ethereum does this via something called KZG commitments, or they will do this in the future, near future. And that's fancy. It's nice. It's a little bit more compute resource intensive, and it doesn't currently allow you to have very large squares at the moment. But eventually, we'll almost definitely switch to something like that. And then currently, we use fraud proofs. But anyway, Blobstream doesn't even verify those fraud proofs, or it doesn't verify these KZG commitments. It literally only checks the signatures from the validators.
Right.
And so it's like the most minimal light client possible.
I mean, a lot of light clients are this way, because I mean, this is similar, I think, to the sync committee. This is similar to IBC. I don't think they do any other validation, do they?
IBC does not yet. They technically allow it, though. You could. Yeah.
Good.
Yes.
Okay, and then so like the basic idea, Celestia's Tendermint consensus, correct?
Yep.
And then so we'll call this Ethereum just for simplicity, but it, as you said, could be other rollups, L3s, L2s. If you have for simplicity of math, you have 3 validators over here on Celestia. Obviously, you have way more. You need at least 2/3 of these people to sign off. The 2/3 of the validator power to sign off, and what they would do is they sign data, and then you can push it over to Ethereum, basically. And on your smart contract on Ethereum, it it knows what your validator set is, and then it verifies that you got 2/3 of those signatures, and then if it did, then the data is correct, right?
Yeah, yeah, pretty much it. And we have a little commitment. So we have a secondary commitment just for Blobstream that's sort of that's the data root for each header. We sort of combine a bunch of those all in one.
Oh, so you guys push over a bunch of blocks all at once, right?
Yeah, we make it. Yeah, we push over. It's kind of arbitrary on how many blocks go in there. I think there's a maximum somewhere, but otherwise it's kind of arbitrary. Yeah.
Yeah. Well, and then I know like so this is like the super simple way of doing it. Um, but then obviously there's a lot of nuances in here because you guys don't. It's not like the validators are just signing these blocks. They actually you guys have like a whole separate peer-to-peer network on the side.
Whoa, we
Correct?
got rid of that.
You got rid of this?
Yeah, now we're
So
using so the cool thing is so previously we had this whole other separate network that was doing this and validators had two keys,
yeah.
which was really frustrating and maybe we can get into that later. But anyway, it was very annoying. They had two keys. That sort of ruins a lot of like the fun properties of this is because if you have two keys and you don't like bake it directly the second key you don't bake it directly into consensus, then you lose a lot of the properties that you want. For example, like you don't have the same liveness guarantees. It's possible, and if when you have two keys and they're not both baked into consensus, that you have the Celestia chain continues to produce blocks, and the data could be available even, and everything's fine. But then the Blobstream, the keys, they don't sign, and you're completely reliant upon social consensus there to be like to slash the validators who are not signing there. So it's very frustrating. We wanted to move away from that as soon as possible. Just two keys is bad. Why do two keys when you can have one key? And the reason for that is because, of course, the EVM has some problems verifying signatures. It's very gas heavy. So especially via the signature scheme that we use for Tendermint consensus.
So they use
So
Enderman uses what EDD and they use
yeah.
something.
Yeah. So yeah.
For people watching,
So
it's the difference between a Cosmos address and an ETH address. Like they're not the same. So you would need, but theoretically you can
it's
just one
even
inside both.
the validators actually use an even a different key. So like they have a validator key and then the address keys. Those are a different scheme. And then
Okay.
but anyway, I'd have to go look at our docs to be honest to go look. I forget all the acronyms. But anyway, the keys that the validators use they they don't verify well on the EVM. So they cost a lot of gas. So that's why we had the second key. But what you can do is you can use a ZK proof. So it's not really ZK, it's just a snark. But you can use a snark and you can verify all of these signatures. And verifying the snark on chain is actually significantly is about the same as verifying the Ethereum friendly signatures. So because they're about the same, gas wise, we use the snark instead, and because it gives us the nice properties that we want, where we don't have to have validators run separate keys. The slashing and the properties is like everything that you expect to happen here with the light client relay is there. So you actually have the guarantees that you want. Um, so yeah, I mean that's pretty
So
much what we do. The
where
validators don't even have to think about it. They don't even do anything different. It's completely up to this whoever is completely free again. Like anyone can create these proofs, these snarks,
okay.
and it's an open source system as well. Uh, so yeah,
So now they're just signing data every block, right? And they would
yep, like normal.
just do normal coming to consensus. So then this person would grab all of these signatures and then they would basically make a proof that says, I guess, what is the proof saying?
The proof that in the circuit is the light client. So it's doing the essentially the exact same things that IBC is doing, except for it's verifying it in the snark.
ZK proof. So would you like you would give it some data and say like I want to prove that this data is in there, or are you just proving the block roots
All we're proving is that you had 2/3 signatures, and you're sort of like following the validator side.
two
So that
2/3 signatures, and then on a given, I guess, what data route be what you're going to be pushing over?
over the past whatever the next few blocks were. So like if I had if the last block height that was updated on the contracts was 100 and now we're at 200, I'm going to prove all of the signatures in the past 100 blocks. And there's an optimization there, but anyway, I'm going to prove those signatures. And then now I have now I'm at block 200. In the past 100 blocks, I'm going to take the data routes so the commitments to the block data for all 100 blocks. I'm going to also prove that in a different commitment that commitment was done correctly, that the Merkleization of those proofs Merkleization of those hashes was done correctly, and then I'm going to post that on the EVM. That's essentially what the proof is proving.
And then, so this would just be, and then you would be pushing some Merkle data route over, and then whoever wanted to prove on Ethereum that their data was available would then look on Celestia and sort of generate where in the Merkle tree that was, and it would prove it out, right?
Yeah, so actually, this is where it gets fun. It's a little
Okay.
interesting. Is if we think about it here, this is we did all this work, right? We've got this light client relay, and it's over on Ethereum. This is great. This is so nice. Oh, but now I want to prove that some data was included. What do I have to do to prove that some data was included? I have to create a Merkle root, and I have to prove the Merkle root. So now I'm posting more data than I used to, right? I have to post the original data and the Merkle proof on top to prove it into the thing. It's less efficient, right? So we did all this work, and then we have this system, right? Instead of posting the original data, I have to do that. So what you can do is it depends on your proving scheme. If I'm an optimistic rollup, the only time that I ever actually have to prove that data was included is when there's a fraud proof.
Right.
So optimistic rollups are insanely efficient using this scheme because how big is your header? That's what you're posting on Ethereum, and that's it. It's insane. Like it's hyper cheap. Now with a ZK rollup, you have to prove it's not optimistic, right? You have to prove it each time. So in your proof is that Merkle proof that we mentioned earlier, where I have the block data and I prove that that block data was included in the data root on the Blobstream contract, and then I submit that. So and I change my proof a little bit in order to include it if I want to be super efficient there. So yeah.
Yeah, I
It
mean,
sort of depends based on the proving system.
right. So, and then I mean, what would be the limit on, like, how many blocks can you guys go? Because this would be like so if I'm a roll up over here off of Ethereum, how the one cool thing I know about this one versus the verifying the normal signatures is you can sort of skip a lot of blocks, right? As far as pushing over, or is it not more?
Both could do that. Yeah.
Okay.
Yeah.
And but is there some point of like, because kind of like you said, you went from block 100 to block 200. Is there a limit to how far you would stretch that,
Yes.
and what would be,
So
yeah, the trade-off?
so that's a great question, and that has to do with tenor consensus. Since we're doing a proof of a light client, right? We have to prove that the starting point um, of the current validator set, right? We're always making the assumption that at least 1/3 is honest, right?
Right.
So if we want to skip blocks, we actually have to prove from the first block, the trusted blocks, the block that's already been verified, we have to prove that 1/3 of that validator set is included on this new validator set. So that's as far as I can go. So if the validator set's not changing, it's unbounded. You can go as far as you want.
Okay.
Like no one could just, everyone could stop caring about Blobstream. No one could produce a proof for a long time, or actually no, for up to 3 weeks. That would be the unbonding window. After the unbonding
Right.
period, then things start to get very very insecure very quickly. So up to 3 weeks would probably be the maximum. It's not unbounded. Incorrect. But it's up to that and anything in between.
Okay. So kind of what you were saying is the unbonding period is like these guys can say, I want to get out. And if they got out and they were still on the validator set here, they could wreck you and it's not, they wouldn't get slashed.
Yeah, yeah, you could have a long range attack with the
Yeah,
old validator keys, and it's essentially free.
right. Um, and then okay, so then you're a roll up, and then I mean in practice, like is there any sense of finality when it comes to so if I'm the roll up, this was always my
Hmm.
question with roll ups, like when is the roll up final? Like if it's an Ethereum roll up posting data to Celestia and then bridging data availability back for, fraud proofs, where in
Hmm.
this chain is this final?
It's very this is fun. This is always a fun question. I love this question
Okay.
because it's always so arbitrary from depending on your point of view. If you're a roll-up full node and I see the transactions, like I download them fully and I operate, this is like optimistic rollup, right? I produce a header and I verify that the header that the sequencer gave me is completely true. We got the same state root. There's no fraud. That's finalized from my point of view,
Sure.
right? So it's very fast. It's a normal blockchain at that point, right? Right. But from the light client, the most of the things that we care about, if you're an L2, right, you don't really care about the rollup full node. You care about the light client, the on-chain light client on Ethereum. You care about that point of view. So most people think about finality from that point of view, and that's like a huge thing. That's like as soon as it gets confirmed on Celestia, that's final, like within one block. I mean,
Right.
you technically you want to wait for fraud proofs, but that's a subjective amount of time. Um, After that, it's as final as it's going to get. And as far as the data is concerned, and then someone will eventually produce a proof and post that on the EVM chain. Now your data is posted, and whenever the sequencer posts their header, then it's completely up to the proving system. So like finality for an optimistic rollup is some optimistic rollups that maybe are a little bit degenerate on most side, closer on the degen side. They've suggested schemes that are like wait 1 day, wait 2 days, like it's good enough. But other optimistic rollups they wait like 7 days or even 14 days. Where like a ZK rollup, as soon as I have my proof, that's final. It's of course you have to wait for Ethereum finality as well, which is like I think
So it would
like
be like pushing from here to
12 minutes.
here over here for a ZK rollup. So once it hits Ethereum and Ethereum finalizes it,
Yep,
then you're sort of final.
yep. As soon as you post your proof, or as soon as so with an optimistic rollup. In both cases, there is in with Blobstream there is a slightly potentially additional delay, because like with an optimistic rollup, normally I would just every single block I would post my header and I post my call data. Um, and then the fraud proof window starts then. But now I wait for Blobstream to confirm that the proof was confirmed on Blobstream. Then I post my header. So however long that period is, so like that will probably be like less than an hour. When it's busy or something, you can I think people can actually request proofs and send fees to the prover now, which is another awesome thing about this new scheme. So it can actually be even faster. So you could if you wanted to, you could create a proof every block. I don't know why you'd want to do that, but you could do it. Um, or you could wait anything in between. So it will probably be like once an hour, but that's like the technically the additional time added here. But if you're like a ZK proof, a lot of them don't post their proofs very often, right? It's like once every 4 hours, 8 hours, or something.
Because it's
So if
expensive
you're
over
doing
here.
that, yeah, exactly. So then no time's added.
Right.
And if you're an optimistic rollup, it's like, well, now I have to wait a week and an hour. Oh, that's a deal breaker. Like as opposed to just a week.
Right. I mean, I guess what's the theoretical limit on how fast you can do it? Because like what's
Oh, every
Celestia
block.
what's Celestia's block time?
Um, Varies about 12 to 14 seconds.
12 to 14 seconds. And then I mean, what's the other one? How long does this proof take?
How big is your cluster? But it's actually a pretty fast proving system.
Okay.
It's I did not create it. I was surprised by how fast it was when we ran it.
So this
Um,
is not the limiting factor, the proof, running the proof.
No. I think it is. Like it's longer than 12 seconds.
Okay.
Yeah. I mean, that's a safe assumption. Yeah.
Cool. Um, so then, yeah. I guess what would be the plan here? Like, would this be the same sort of bridge that you guys would use? You know, like I know you guys had talked about like let's say there's a roll up here and another like let's say there's like five roll ups that are all using this as data availability. Would they be using this same sort of proof structure to grab stuff and sort of bridge between chains themselves?
Mm, If
Or
they didn't want to go through Ethereum, that is an interesting question. So, yes, if they didn't want to go through Ethereum, you could have I don't want to use the word trust minimized, a bridge with reduced trust assumptions
okay.
by having this Blobstream verify on both chains. So both chains are verifying that the other chain did actually post their data, and they have fraud proof. So like you like this is like what an L3 would do. An L3, this chain, it's not even connected to Ethereum. It's only connected to a different rollup. And the L3 probably, if they're running full nodes of the L2 and of Ethereum, I don't think that they have to have the Blobstream contracts there. There's I have to think about that. But the L2 in this case would have to have the Blobstream contracts posted on it. It verifies that the data was posted. And the L3 or whatever bridge rollup chain has to prove to that L2 that it actually posted data there.
Cool. All right. And then I think I have one more question, but I probably have a whole bunch. But this would be I know that Celestia is really big on the idea of sovereign rollups. So the idea, yeah, you can see, you know where I'm going with it. Like, you know, like whenever you talk about this roll up, like sovereignty usually means like the ability to fork. That's like how I would say, like,
Yeah, that's my definition.
how would sort of that work in this whole scheme? Like, basically, they would have sovereignty until they post it over to Ethereum, or it would be, you know, like where
Yeah.
would that go?
So this people's opinions on this vary. I'm only speaking for myself here.
Their opinions
With
vary.
sovereignty, yeah, like people have very different opinions, and it's very cool. My definition of sovereignty is like the credible ability to hard fork.
Right.
So if I'm an L2, I can hard fork. I'm just a blockchain. Every blockchain can hard fork, but it's the consequences of that. It's like well, I can hard fork, but if that means that I can't use my contracts and all of the funds on my rollup went there, it's like, can I really hard fork? It's like, I don't know, but probably not. Whereas like another chain where a lot of assets are defined on it, and it like its own assets, its own settlement layer, right? Then in that case, well, it's just like you the other bridges in this case, you still have the same bridge and they still function the same way, but you're like, I hard forked. You guys are just going to have to deal with it. Like I had an upgrade or I did something, and you can have various different schemes for that. And again, very dependent upon your proving system, right? Rollups don't rely on an honest majority for the validity of the state. Therefore, upgrades are more complex because usually when an upgrade occurs, something occurs with the state. Like the state machine changes, there's a hard fork, and you want to slash somebody or something. Something happened with the state. Like with an optimistic rollup, I have to have now whatever changes to my state machine occurred, I have to upload those state machines somewhere else. So like on Ethereum, that's the rollup contracts for the optimistic rollup. I have to change those contracts. Somebody has to change those contracts. Is it a multi-sig? Is it governance? Is it something? I'm not sure. There's no like real good way around that, right? It's a bridge. It's the same issue everywhere. So the idea of a sovereign rollup is just that to me, I mean, it's just you're just your own chain, and you're just, like you're just a normal chain. That's it. Like there's really nothing else to it. Like you're like just how you would consider a Cosmos chain. Like in the past, Cosmos chains have had the IBC bridges. They sort of had to either unfreeze via governance, or they had to manually hard fork to update the IBC client so that they could reestablish the connection to a different chain, something like that. Like things like this have happened before. So you kind of just figure it out. like that sounds stupid, but after I said it, I was like, oh, that sounds stupid. But I mean, it really does happen. Like if the governance on the other chain, if they have governance, has to do something, or the multi-sig has to do something. It's very arbitrary to each situation. Um,
Well, I
and
mean, are there plans, I guess, on the Blobstream contract in Ethereum? Are there plans to sort of like have like an owner or something like that who could recognize
Yeah,
this?
I think we have for now. I think we have a upgrade contract, at
Okay.
least at first. Um, we don't like governance here over in Celestia land, so I'm presumably we would like long term if everything's like settled. Like I could totally imagine a scenario where we upgrade to a contract that has no multi-sig controller. It's final. It's like if it breaks, it's broken forever. Too bad.
But you would say that whoever is the user of the data, so the rollup that needs the data over here, they should probably use some contract that has that ability, or I guess unless you
Well,
don't want to.
oh man, we're getting a little political. Um, no, because like right, a lot of people don't consider rollups full rollups if they have that committee, if they have that multi-sig, right? Because it's kind of a big security flaw. You're not really having the full security of the L1 there because this committee, if they somehow get corrupted or someone steals their keys, well, it kind of doesn't matter that you have this amazing proving system because we can change the contracts.
Right. Yeah.
Yeah. So some of the definitions of a rollup are very strict, and I think for a good reason. And they involve having contracts that are not upgradable. And at that point, you have to like the only way to upgrade is to migrate your own state. So this is like right when you're upgrading, you have two options. On if you're on your own chain, you can hard fork. You can upgrade via social consensus. It's the most secure way. The second way that is, or yeah, I guess there's three ways. The second way is that users have to migrate their own state. So I deploy new contracts, and users have to exit the one rollup, go to the other rollup, enter there. And then you have the third way, of course, which is like having a multi-sig or governance, token voting, etc., something equally
Which is what
bad.
probably most of them do at the current moment.
Yeah, at the moment.
Yeah. Well, I mean, that's like I've
In the
always said.
future, though, I don't think we will.
I've said like maybe this could be a potential thing for like maybe a use case for like restaking. Like you could use like Ethereum social layer to pick the social layer or something like that. Um,
Yeah, yeah, I guess I could see that. To be honest, sometimes I don't feel like I understand restaking. That's a separate issue.
no, that's I love how you explained zero knowledge proofs and cross chain bridging, and you're like, ah, man, restaking. Forget
I, I
about
I
it.
think I'm just missing something simple about it. Yeah,
Uh,
sometimes I don't understand like how the slashing actually occurs or how you actually add security there. Like for an oracle, right? Like kind of like what we described with the light client relay. One of the
Right,
differences there with a oracle is that you can actually slash things because but that slashing requires the ability to hard fork. So if I don't have the ability to hard fork, then I'm relying on token voting to slash me. I don't know. Like this is like a gap in my
right.
knowledge where, yeah.
Yeah, no, I actually my previous episode I had on Slinky, which is the skip protocol guys. And
Oh, I love Slinky.
yeah, but
Yeah,
you know, like they're actually calling it like a restaking oracle. Um,
yeah, that's fancy. That's cool.
yeah, which it's a weird way to sort of say your validators are your own oracle. Um, like you know
Yeah,
what I mean? Like so it's sort of different and people are playing around with it, but I could see something similar.
yeah.
Yeah,
I really like oracles like that are socially slashable, where you have a block validity rule that says like literally I cannot produce a valid block without having an oracle update. It's like that's an amazing property. That's like a superpower. So I'm a huge fan. I'm a huge fan of everything Skip does, but of course of Slinky as well. Yeah.
yeah, they were super cool. Yeah, I mean, I think it's like obviously like it works depending on obviously you probably have a very Cosmos-esque vision of the world in that there's going to be lots of chains for lots of different things. You know, like if you had a monolith
Yeah, yeah.
chain, the idea of a monolithic chain running thousands of oracles is also really scary in a different way.
It is, isn't it?
Yeah, so um, you sort of have to caveat based on your own vision. But yeah, it's cool. Anyway, am I missing anything? What didn't we hit that I could potentially throw in there?
Um, I think that's it. We covered just about everything. Blobstream is in itself is relatively simple.
Right.
It's on purpose. It's meant to be very simple. And in the future, we might upgrade it to have things like more block validity rules. For example, if we have a some sort of snark that proves that the error share encoding was done correctly, then we might add that. Another thing that we're thinking about is like since we use SHA-256 for that committing that data root, for ZK rollups, it's extremely expensive. For the prover, it dramatically increases proving costs when you have to verify things like that. So one thing that we would do is sort of batch that cost all together, and we have two data roots, and we have one that's made with something like Blake 3 or Poseidon, and then we have the normal data root that's just SHA-256. And we actually prove that those data roots are over the same data. So we have two different roots, but they're over the same data. And the reason why that proof would be very nice is because something like a ZK rollup can just use the snark-friendly hash function to prove the Merkle root, and it makes their proving significantly cheaper. So there's other things that we can do to Blobstream in the future that I'm very excited about that we can continually add. Anything that we can use to get like fancier with these validity proofs, and then even like bundle them together, right? That's sort of been, I guess, a narrative recently is sort of like bundling these proofs together. Yeah, I'm pretty excited about it. Eventually, we'll have one proof to rule them all.
Well, I think it's like the idea of just like how can you make this faster and this reading much cheaper? And that would be like the idea. Like if you could just if it was basically like very minimal gas, you're posting to Ethereum basically as often as you want, and you can prove whatever you want really, really cheap. That would be like the perfect scenario for sort of everyone involved, and we're just working.
Yeah, I mean, there's all sorts of crazy fun things that we could do in the future. I don't know if you just saw I think the Cosmos Hub and Informal had a recent thing where they can, for some attack vectors, you can actually have slashing from Bitcoin. So there's still I still have some questions about that exact system, but potentially you could have something even like that, where Celestia gets some security from something like Bitcoin,
You could have
which
like
is
a
kind of a crazy
Bitcoin and
idea.
Ethereum roll up on Celestia.
Yeah, yeah. And so, oh my God, I just thought this would be the funniest thing is like you can have rollups on Bitcoin, right? And you can have something like Blobstream verified on a rollup that is on Bitcoin, right? So you're having this off-chain DA for rollups on Bitcoin, and then now we're going to circle back, and we're going to for some attack vectors we're going to have Bitcoin help secure Celestia, right? Which is kind of crazy to think about. Um, and,
You
yeah,
could
it's just
like
a ton of
make
fun. There's
ETH.
so much.
You can make ETH and L2 on Bitcoin, and it'll be yeah, make everyone's head explode.
Oh, we could do it. It'd be fun. Why not?
Yeah. No,
So,
but
yeah, someone's going to do that. Is you can post all of the Ethereum blocks onto Celestia because it doesn't cost very much. Um, that's like a fun meme. Um, who came up with the phrase? Oh man, there's infrastructure as a shit post or infrastructure as like a meme or something. Yeah, yeah, it's really fun. It's like the only thing better than just like a meme is like you build like a crazy stupid thing that's probably impractical, or maybe not even that impractical. It's just like a monument of like nothing. I don't know. It's just great. I love it. Yeah.
very nice. Um, all right, well, to wrap up, where can people find more and find you?
Yeah, Celestia.org, Celestia.org is probably the best site to get started. We have a lot of good documentation. I think we have links to our specs. So if you enjoyed this talk, we got kind of low level, then you probably would enjoy our specs. And we explain a lot more of these things. You can go down some rabbit holes. If you have any questions, you can ask me on Twitter or Warpcast. On Webcast, I think I'm just at Evan Forbes on our forecaster. And then on Twitter, I think I'm Evan S. Forbes. All one word. I run a validator. If you have some Celestia tokens and you want to delegate to my validator, I donate 100% of the revenue, not even just the profits. Well, currently, maybe that might change if the costs get too big. But anyway, currently, I donate 100% of the revenue for open source research and open source software to CUC committees. So the name of the validator is actually called CUC, which is supposed to be spicy on purpose. It's I have to I don't we might not have time to explain it all, but the idea here is that, right, with a light client, you're not really trusting these validators. Is the validators are operating but on your permission because you're the one verifying things. And this can go all the way down from things like MEV capture. And like you just don't, why trust a committee if you don't have to? So you cuck the committees, right? So that's where that meme comes from.
Love it. Yeah.
And that's the name of my validator. It's supposed to be funny or ironic or something. I don't know. Maybe I stare at computers too long. And yeah, so you can delegate to me. It's just called Cuck. I don't know the address off the top of my head, but you can also find that on Twitter, Cuck_Cuck_.
Nice. Yeah, this was an awesome episode. Thank you so much for coming on. I definitely learned a whole lot about Celestia and Blobstream. So, yeah.
My pleasure.